Welcome back, everybody. We are continuing our study on R.3 with polynomials. The first thing that I want to talk about with polynomials before we fill this stuff in is that polynomials have a standard form. And the standard form means that the terms are in order from the highest to the lowest exponent. The product of a number and one or more variables raised to a power, remember that could even be a 1, is called a term. The number is the numerical coefficient, but we're used to just calling it the coefficient of the variable. Like terms are terms that have the same variables raised to the same powers. A polynomial is a term or a finite sum of terms with only positive or zero integer exponents permitted on the variable. If the terms of a polynomial contain only the variable x, then the polynomial is a polynomial in X. The degree of a term with one variable is the exponent on the variable. The greatest degree of any term of a polynomial is the degree of the polynomial. A polynomial containing exactly 3 terms is a trinomial. Tri meaning 3. A 2-term polynomial is a binomial, bi meaning 2. And a single-term polynomial is a monomial, mono meaning 1. So that's a little bit of our vocabulary. The ones that we're used to talking about most often are going to be coefficient, polynomial, degree, and then monomial, binomial, and trinomial. So let's talk about polynomials. Letter A, 7, 3, and 2 are all positive. So this is a polynomial. The degree is the largest exponent. The largest exponent is 7. And so this is a 7th degree polynomial. And there are 1, 2, 3 chunks or terms. And so since it specifically is 3 terms, then this is considered a trinomial. For letter B, when we first look at letter B, we're seeing the t to the positive 4th and then t to the positive 2nd. However, this t to the 2nd is underneath a fraction bar. That really means that that's t to the negative 2nd. Once we've gotten to the point where this is not positive, then this is not a polynomial. If it's not a polynomial, we cannot give a degree, and we cannot classify it as monomial, binomial, trinomial, or none of those. If it were a polynomial, and this was a positive 2, then we would say, well, this is a 4th degree, and being that there are 2 terms, it's a binomial. For letter C, this is a polynomial. We don't really care about this negative 4/5 in the front. Again, we're looking here at the 3 and the 2. Those are both positive. And so, yes, this is a polynomial. All exponents are positive. And so the degree is actually a 5th degree. There's only one term, and we would add the exponents here to get the degree. Because this is only one term, and we know it's only one term because over here in A we had plus and minus. In B there's 2 terms here because there's a subtraction that's separating the 2. In letter C we have nothing separating any of these. And so since there's only one term, this is a monomial. Underneath there, it says reflection. And so this is what I'd like you to add there. A polynomial, so this has nothing to do with this. We're adding to the bottom underneath those examples. A polynomial has positive whole number, meaning no fractions, exponents only. So they would not have an x to the 3/5, right? That's not a whole number. Would not have an x in the denominator. Would not have a negative exponent. And it would not have an x in the exponent. So those would not be polynomials. All right, adding and subtracting polynomials. When we add and subtract polynomials, we add like terms. Exponents do not change. We just want to know how many of each of those we have. Like terms, remember, have the same variables with the same exponents. So I have y to the 4th and y to the 4th. We have 2 here plus 4 here to make 6 y to the 4th. Y squared and y squared, negative 3 plus 7 is 4 y squared. And then y plus 6y, remember there's a 1 here, so 1y plus 6y gives us 7y. This is in standard form. We have 4th power, 2nd power, 1st power, and none of those are like terms for me to be able to combine them any further. For letter B with the subtraction, you don't have to do this, but I like to do this. I like to go ahead and distribute that subtraction to everything on the right. And that basically means now we've changed this to an addition problem and we've changed all of those signs. We're again looking for like terms. Now don't be fooled. Sometimes they're going to put like terms in the same spot and sometimes they're not. I think for most of these ones they are. We have negative 3m to the 3rd plus negative m to the third. Remember, there's a negative 1 there. So negative 3 plus negative 1 is negative 4 m to the third. Negative 8m squared plus negative 7m squared is negative 15m squared. 4 plus 3 is 7. This is in standard form because I go from third power to second power to no exponent. And none of these are like terms for me to be able to combine those any further. For letter C, got to make sure that we're very, very careful at this point, as we're starting to add in some different letters. So I have 4, m to the fourth, p to the fifth, m to the fourth, p to the fifth. All right, and we're adding. So 8 plus 11 is 19, m to the fourth, p to the fifth. M to the third, p to the fifth, m to the third, p to the fifth. So those are like terms. Negative 9 plus 15 is positive 6, m to the third, p to the fifth. This is in standard form. We have m to the fourth coming before m to the third. M comes before p in the alphabet. So technically that's how we would arrange these into standard form. And I can't combine those because there's no more like terms. For letter D, let's see, purple. I need to start with distributing so we can free up the parentheses and find out what all we have there. So 4 times x squared is 4x squared. 4 times negative 3x is negative 12x. 4 times 7 is positive 28. We're going to take the negative with the 5. So we're adding negative 5 times 2x squared is negative 10x squared. Negative 5 times negative 8x is positive 40x. And negative 5 times negative 4 is positive 20. Now I can combine my like terms. I have 4x squared plus negative 10x squared. That's negative 6x squared. Negative 12x plus 40x is positive 28x. And then 28 plus 20 is positive 48. I want to go back for just a second and talk about degree and polynomials. So these are polynomials. Example A is a polynomial. We have a positive 4, a positive 2, and a positive 1. The degree here would be a fourth degree. And there are 1, 2, 3 terms. So this would be a trinomial. I know it doesn't ask us that, but we want to practice that. For letter B, this is also a polynomial. We have a positive 3, a positive 2, and then no variable over here. That means that this would be a third degree. And there are 1, 2, 3 terms. So this would also be a trinomial. For letter C, this is a polynomial. Our exponents are all positive whole numbers. This would be a ninth degree. We would add the 4 plus the 5 here to make this a ninth degree. And there are 2 terms here, so this would be a binomial. And then for letter D, this is also a polynomial. This is a positive 2, a positive 1, and then we don't have to worry about the 48. So positive whole numbers. This would be a second degree because our highest exponent there is 2, and there are 1, 2, 3 terms, so this would also be a trinomial. The last part that we're going to talk about is multiplication. So we're talking about what are some ways that we can multiply polynomials. And there are actually several ways. The way that we are most familiar with is distributing. So I will start with distributing. And it doesn't matter when we're multiplying if they are like terms or not. So we take first term times everything over on the right side. Remember, when we multiply, we add exponents. So 3 times 1 is 3. P squared times p to the third, 2 plus 3 is 5. 3 times 2 is 6. P squared, this is p to the first. So 2 plus 1 is 3. And then 3 times negative 8 is negative 24. Oops. And then we keep the p squared because there's no p with the 8. Negative 4p, we're going to distribute to everything. Again, this is p to the first here. So negative 4 times 1 is negative 4. P to the first times p to the third, 1 plus 3 is 4. Negative 4 times 2 is negative 8. P to the first times p to the first, 1 plus 1 is 2. Negative 4 times negative 8 is positive 32. And then we have that p. Last but not least, we have the 1, the positive 1 that's going to go to all three of those. So 1 times p cubed is 1p cubed. We can put the 1 there. We don't have to. 1 times p to the 2p to the first is 2p to the first. And 1 times negative 8 is negative 8. Notice how I've color-coded everything that I've done here. Maybe that might help you in organizing everything. And I've also already taken care of lining up like terms. Again, it's more to try to help simplify when we're adding like terms rather than making it a long list that just kind of goes on and on and on. But again, however you choose to do it that you're comfortable with. Our last step is to come and take care of all of our like terms and get our final answer. 3p to the fifth has no like terms, so we're dropping that down. Negative 4p to the fourth has no like term, so we're dropping that down. 6p to the third plus 1p to the third is 7p to the third. Negative 24 plus negative 8 is negative 32p squared. 32 plus 2 is 34p, and then we have that negative 8 that has no like terms. Now we've taken care of writing this in standard form. This goes from fifth to fourth to third to second to first to no. So everything is in order from greatest to least. If we're looking at degree, this would be a fifth degree because our largest exponent is a 5. And there are 6 terms. Because there are 6 terms, there is no special name for this except for just polynomial. So we don't call it a binomial, trinomial, monomial, or anything like that. We just call it a polynomial. FOIL is another method that we've used prior to this for multiplying. Remember, FOIL stands for first, outside, inside, and last. It's kind of fancy distributing because that's basically what we're doing. First, outside. So 6m, remember these are first powers. 6 times 4 is 24. M to the first and m to the first is m squared. 6 times negative 3 is negative 18m. And then on the inside, we have 1 times 4 is 4m, and 1 times negative 3 is negative 3. Our like terms are going to be on the inside next to each other. So we don't really have to do a whole lot of searching with that, which makes our final answer 24m squared. Negative 18 plus 4 is negative 14m minus 3. This is a polynomial because we have positive whole number exponents. It is in standard order, 2, 1, and then nothing there. This is a second degree polynomial. And 1, 2, 3 terms, so this would be a trinomial. Another way that I like to do my multiplying, and you can use this method for any combination of size of polynomials. So it works for binomials, trinomials, polynomials, any size. If you think back to science in genes, and you had your alleles, and you had your dominant and recessive, that you combine together in these boxes. And so I call this the Punnett square method. It doesn't matter which one you put on which side, but basically what we start with is we multiply whatever is touching the box. So this box has 2x times 2x, which is 4x squared. This box would have 2x times 7, which is 14x. This box touches the negative 7 and the 2x, so negative 7 times 2x is negative 14x. And then negative 7 times positive 7 is negative 49. Our like terms, most of the time, are diagonal. And this right here is kind of a giant plus sign, which says add your like terms in here and write them out. 4x squared does not have a like term. Negative 14x plus 14x actually adds to 0. And then negative 49 does not have a like term. And so our answer to that multiplication, our product, is 4x squared minus 49. This is a polynomial because the exponent there is a positive whole number. This is, again, a second degree because 2 is our largest exponent. And we have two terms here, so this would be a binomial. Last but not least, we have example C. And I'm going to start with having this r squared. You can either multiply it to the first set or the second set, but you have to be careful that you don't multiply it to both. I'm going to go ahead and distribute it to this first set, which will make this 3r to the third plus 2r squared times 3r minus 2. From here, I'm just going to do regular distributing. So 3r to the third times 3r. 3 times 3 is 9. R to the third and r to the first is r to the fourth. 3r to the third times negative 2. 3 times negative 2 is negative 6. And we just have r to the third. 2r squared times 3r to the first. 2 times 3 is 6. R squared and r to the first is r to the third. And then 2r squared times negative 2. 2 times negative 2 is negative 4. And we have that r squared. Our like terms are right here. Negative 6r to the third plus 6r to the third. That adds to 0. So that zeroes out, which means that we're left with 9r to the fourth minus 4r squared. This is in standard form because we have 4 and then 2. It's going from greatest to least. It's a polynomial because these are positive whole number exponents. This is a fourth degree because our largest exponent is 4. And there are two terms, so this would be a binomial. This is where we are going to stop for today. Thanks so much for joining me. See you next time.